Today we are going to make barbituric acid. Barbituric acid might possibly be restricted or outright illegal to make or possess where you live. Fortunately, barbituric acid isn't psychologically active. In Germany, it's perfectly legal to make and possess. I could even buy it. For this project, you will need 40 grams of diethyl malonate. Furthermore, 15 grams of urea, 5.75 grams of sodium, we used 5.8 grams, 250 milliliters of dry ethanol, 33% hydrochloric acid, and lastly 240 milliliters of distilled water are needed. We then start off by weighing out the 5.8 grams of sodium metal. The sodium metal was wiped dry to remove any paraffin that stuck to its surface. Afterwards, 125 milliliters of dry ethanol were measured out and added to a 1 liter round bottom flask. A stir bar was placed into the round bottom flask. Afterwards, all of the metallic sodium chunks were directly thrown into the dry ethanol. The sodium will react with the ethanol, forming sodium ethoxide and releasing a lot of heat and hydrogen gas. To keep down the ethanol that will inevitably start boiling, a reflux condenser was connected to the round bottom flask. The flammable hydrogen gas was led to the outside world through this hose. It took approximately 10 minutes for all of the sodium to dissolve. When the sodium had dissolved, the gas outlet tube was switched out for a drying tube. The drying tube is filled with calcium chloride to prevent any water from entering the apparatus. Any water present will decrease the yield, therefore the ethanol also has to be as dry as possible. 40 grams of diethyl malonate were weighed out. The reflux condenser was then removed and the diethyl malonate was added to the round bottom flask. After the addition, this white solid chunk was formed. 15 grams of urea were weighed out and dissolved in 120 milliliters of ethanol. By the way, I dried the urea over anhydrous calcium chloride in a vacuum desiccator overnight. The urea-ethanol mixture was left on a hot plate until all of the urea had dissolved. The hot urea in ethanol solution was added to the 1 liter round bottom flask. Now look closely at the Erlenmeyer flask. What's interesting is that upon cooling, those nice urea crystals formed on the wall of the Erlenmeyer. The flask was swirled with a small amount of ethanol, which was later on also added to the reaction flask. This allowed us to transfer the urea that had crystallized on the walls into the reaction flask. The reflux condenser was then lowered down. This is what the mixture looked like. To get the reaction going, heating and stirring of the heating mantle were turned on. The reaction taking place here can be seen above. The diethyl malonate reacts with the urea, catalyzed by sodium ethoxide to form barbituric acid. For every mole of diethyl malonate consumed, 2 molecules of ethanol are split off. We allowed the mixture to reflux for 7 hours. What I found interesting was that after some time, what I guess was barbituric acid had settled on the top and on the bottom of the condenser. It's strange that no solid had settled on the walls in the middle of the condenser, but only on the top and on the bottom. After the 7 hours have passed, 220 milliliters of boiling distilled water were added to the reaction flask through the top of the reflux condenser. I chose to add it this way to flush down all of the barbituric acid that had settled in the condenser. Heating and stirring were continued for 10 more minutes until we were left with this clean solution. Now the solution has to be acidified. The solution is basic because sodium methoxide will react with water to form sodium hydroxide. The sodium hydroxide will in return react with the barbituric acid, forming sodium barbiturate. Because we want barbituric acid, we have to add hydrochloric acid to turn the solution slightly acidic. Sodium hydroxide and sodium barbiturate will react with hydrochloric acid to form sodium chloride, and the sodium barbiturate will react with it to form barbituric acid. In total, approximately 40 milliliters of 33% hydrochloric acid were added until the solution was slightly acidic. At some point, the pH paper turned red. This meant that we were finished with the acid addition. The round bottom flask was stoppered and put into a fridge. In theory, the barbituric acid should simply crystallize out during this time, but in our case it turned out not to work like this. Sadly, even after a week, no barbituric acid had crystallized out of solution. Therefore, this will be the topic of another video, and you can definitely stay tuned for this because I will find a way to squash every gram of barbituric acid out of this solution. So stay tuned for part 2. I wish all of you a nice day. Until next time.